In this lesson, we'll be talking about parallel and perpendicular lines. Let's jump right into the definition of these. Two lines are parallel when they have the same slope, and this means that they never intersect. In addition, any two vertical lines are also automatically considered to be parallel. Parallel means that the lines have the same slope. On the other hand, perpendicular. Perpendicular lines intersect at a right angle, and perpendicular lines have a negative reciprocal between their slopes. These two definitions you're going to need for the whole lesson, so you want to spend a little bit of time thinking about it and commit it to memory. Parallel means same slope. Perpendicular means negative reciprocal slope. First off, let's do a couple of quick examples of what the graphs look like. In the previous lesson, we learned how to graph by slope-intercept form. And so for the first line, 2x minus 1, my y-intercept is negative 1, and I'm going to rise 2 and run 1 to get my second point. And then for the next one, 2x plus 3, I'm going to start at 3 for my y-intercept. Now rise 2 and run 1 for my second point. And so I end up with these two lines. Notice that they do appear to be going in the same direction and that they'll never intersect. This is the concept of parallel lines. Same slope goes forever without ever intersecting in the same direction. Next example. For this one, this is what I'm talking about with negative reciprocal. Notice that 2/3 is the slope of the first line, but for the second line we've got the negative of this slope and we've also taken the reciprocal. So instead of positive 2/3, we get negative 3/2. So this slope is the negative reciprocal slope. With that said, we will expect these lines to look perpendicular. Let's check it. So drawing 2/3 x minus 2, I'll first draw the minus 2, and then to do the slope I'm going to rise 2 and run 3. So this is what I end up with. Something like this is what the line's going to look like. Next one is negative 3/2 x plus 2. So let's graph plus 2. Negative 3/2 means fall 3 and run 2, which looks like about right here. And now let's draw this line. As you can see, it does appear that these lines intersect in a right angle, which is exactly what we would expect because the slopes represent perpendicular lines. Let's try to do one. Find the equation of a line that passes through the point 0, 2 and is parallel to this given line. And then we're going to graph both of them. Parallel lines have the same slope. That's important. So the first thing we need to do is figure out, well, what is the slope of this line? Probably the easiest way to find it at this point is putting it in slope-intercept form. So if I subtract 3x from both sides, I get 2y equals negative 3x minus 2. And so dividing by 2, I get y equals negative 3/2 x minus 1. The one thing that students commonly do that messes them up is they look at this and they pay attention to the whole line and they try to do something with this whole line, but that's not the point. You just want to find an equation of a line that's parallel to this one and passes through 0, 2. So all you want to pay attention to is the negative 3/2. The negative 3/2 is the slope of the line, and remember, parallel lines have the same slope. So my m for this particular parallel line is negative 3/2. Negative 3/2 is the slope. It's going to pass through the point 0, 2. Now the point 0, 2 is a y-intercept, so we can take a little shortcut here. 0, 2. Well, what we can do is just say, well, y equals mx plus b. No extra work. We know the slope, we know the y-intercept, and this is the line parallel to the original line that we were given. All we needed from that original line was the slope. However, since they've asked us to graph both lines, it will help us that we wrote it in slope-intercept form. So we have negative 3/2 x minus 1 is the first line. So minus 1 is my y-intercept. The slope is negative 3 over 2. And so my line is going to be like this. And then the next one, I'll color it in green. Negative 3/2 x plus 2. Well, I start at positive 2. I'm going to go negative 3/2 again. So here's my line. Fall 3, run 2. And you'll notice that these lines do look parallel, as you would expect. Next example. This one is now exactly the same idea, but this time they want to know the line that passes through 0, 2 and is perpendicular to the given line. All that we need out of this first line is the slope. What that means is now we need to calculate the slope of our new line. Our new line is going to have the negative reciprocal of that slope. So a negative number will now become positive, and the reciprocal of 3/2 is positive 2/3. That's our slope. With that said, the point 0, 2 is still really easy. We're not given anything difficult here. All we need to do is just say y equals mx plus b. That's the answer that we're looking for. Nothing too difficult. So y equals mx plus b gives me my line. Again, perpendicular. The slopes are negative reciprocals of each other. So now we'll go ahead and do this again. We'll draw the equation of the line. Y-intercept is negative 1. And the slope is negative 3/2. Just drew this line on the previous slide. There's the line. And then the second one, my y-intercept is 2. And I'm supposed to use the slope 2/3. So that's rise 2 and run 3. Notice that they do appear to intersect at a right angle up to the drawing of my picture. Now we've got a slightly harder point, and this time we're wanting to find the equation of the line that is A, parallel, and B, perpendicular. So we have two problems to do. Then we're going to graph all three lines. For A, my M is going to be the same as the slope of the line I'm going to be parallel to. Remember, parallel lines have the same slope, so I get negative 2/3 as my slope. Now, I'm just going to use the point slope form. Y minus, if I label these x1, y1, it's y minus y1 equals the slope times x minus x1. So I get y minus 1 equals negative 2/3 x. Now this was a plus 1. So distributing the negative 2/3, I get minus 2/3. Adding 1 to both sides, I get y equals negative 2/3 x plus 1/3. That's the answer for A. This line is parallel to the original line. B. Remember, perpendicular lines have a negative reciprocal slope. So since it was negative 2/3, now it's going to be positive 3/2. And then we'll do the same thing. Y minus the y-coordinate equals your slope times x minus the x-coordinate. I get y minus 1 equals positive 3/2 x. It's going to be a plus 3/2. And so adding 1 to both sides, I get y equals 3/2 x plus 5/2. That's the perpendicular line through that point. Let's draw these lines. Negative 2/3 x plus 4. I'm going to fall 2 and run 3 to get this first line. Next one I'll draw in green, and that's the parallel line, so I should expect it to go the same direction. If I'm starting at a y-intercept of 1/3, I need to fall 2, 1, 2, and run 3. 1, 2, 3. And I'm at the 1/3 mark, not at an integer point here. So when I draw the equation of the line, there's your negative 2/3 x plus 1/3. Next one, I'll draw this one in red. This is the perpendicular, so it should look perpendicular to both. 5/2 is my slope, and I need to rise 3 and run 2. Now, I don't like drawing a point up here off the graph, so I'm going to show you the other way you can do this. I could go backwards. think of like a rise 3 and run 2 from over here somewhere. I'll go backwards 3, 1, 2, and 3, and go backwards 2. That's another way to calculate that. So here's the equation of the line. Something like this is the graph of the line. And it looks perpendicular to the blue curve. The green curve isn't perfect because I didn't draw it that well. But the idea is that these numbers are the same slope being the parallel, and negative reciprocal slope being the perpendicular.